We're first going to review the basics of what makes up a DAS system. For those of you that may have not seen one before, I promise no engineering details, just the high-level visuals. The fire codes and other regulations have been evolving in recent years as technology has changed, so we're going to discuss some of those new requirements. And finally, we'll share some best practices that we've seen in installations in the field. Okay, so what's the issue? Obviously, what happens when there's an emergency in a public building? The first responders' radio systems don't work, so they can't communicate with each other. The coordination becomes problematic, mistakes can happen, causing injury or, in worst cases, loss of life. A local example of this is the Social Security Administration. About 4 years ago, there was an emergency. The fire department was called. They responded, but realized that the deeper they went into the complex, the less reception they got on the radios, to the point of complete failure. The administration then installed a DAS for public safety and have since added their private 450 megahertz radio system onto that DAS for all their floor leaders to have radio communication. Today in our area, the Mid-Atlantic region, most counties and or cities have built their own radio system to solve this problem. With a single radio system on a single frequency, all first responders are issued radios that are set to that frequency, allowing interagency communication wherever there is signal. But today's topic is what happens if the system's radio signal doesn't penetrate a specific building. We're going to go into why that might happen later, but it's obviously a problem. When you go into some of the older buildings, you'll notice the traditional fixed fire phones that you've seen in elevators where the firefighter plugs into the system. That system isn't as flexible as today's technology allows, and some of the authorities are moving away from that type of system. So a distributed antenna system solves that problem. So the anatomy of an antenna system, it's really very simple. There are only a few piece parts that work together to provide enhanced signals in a building. On the left, you see the transmit tower. It's marked cell signal, but that could very easily be marked public safety signal. That's sending the signal. Then you go to the top of the roof. There's an antenna on the roof that receives the signal and sends it to a bidirectional amplifier, a BDA, that distributes it throughout the building through coax cable and placement of indoor antennas. Although each building design is unique, the basics are usually the same. So you see the bidirectional amplifier, you see some indoor antennas. Usually there are 2, 3, or 4 per floor, depending upon the size and complexity of the buildings. And then there's cable throughout. Very basic. That's all there is to it. This is a picture of some typical BDAs. The one on the left is actually designed for public safety. It's in a red NEMA enclosure box, meaning it's fire and waterproof. There's the gray panel there that actually attaches to the fire panel. We'll talk about all this later. And on the right-hand side, you see another model. The gray boxes below are the uninterrupted power supplies, battery backups. We'll go into those in a minute. Antenna types. On the right, you see a directional antenna. That's called a Yagi. That's the antenna that's on the roof of the building that points to the tower, whichever tower is generating the public safety signal. And then the antennas on the left, that's one type of antenna. That's the interior antenna. They're usually mounted on the ceiling. They're aesthetically pleasing. Most of the time, you don't even know that they're there. So there's a lot of engineering put behind these basic elements of a distributed antenna system. RF propagation software design program from IBWave is the industry standard. That's what most people will use when designing an in-building system. So some factors affecting the existing coverage of a building today. This is not new construction, but every building reacts to radio signal differently due to the materials used for construction. The building shown on this slide is actually the John and Francis Angelos Law Center at the University of Baltimore. This is a brand new building. You can see lots of very good looking glass. It's LEED certified. LEED is Leadership in Energy and Environmental Design, so it won all kinds of awards. It's rated with lots of energy efficient glass. So that's all good for energy savings. The problem is that all the coating and all this glass makes it so energy efficient actually reflects all the RF signals and prevents radio reception inside. So obviously the City of Baltimore Police Department's radios were not working inside that building right after construction, so they installed the DAS and everything is working fine. Another thing that affects coverage is proximity to the transmission tower. How far away are you? The farther away you are from the tower, the weaker the signal is. Pretty simple. Density in construction means density of materials in the building itself, and also density of the environment. Are you located in a city with a lot of tall buildings around you? Those buildings may prevent the public safety system from penetrating. And obviously below ground levels, underground parking, very often low coverage areas. So the environment is changing. Unfortunately, almost every day brings news of fires, violence, terrorism, which are all broadcast all over the media. What about situations that aren't mass media subjects? Daily occurrences, even the concern for public safety communications in all buildings. So building management companies, building owners, they're all getting very concerned about this. Many counties, townships are writing ordinances that dictate the requirements for signal strength in buildings for public safety radio systems. These are enforced by the AHJ. We're going to be talking about that throughout this presentation. AHJ is the authority having jurisdiction. This is most often the fire marshal for that municipality or for the county. We're going to talk about coverage requirements. Coverage requirements, critical areas are stairwells, mechanical rooms, and most codes say that they've got to have 99% coverage. General areas are lobbies, common areas, and usually that requires 90% coverage throughout the entire building. The test that we use, and we'll get into the details of that, is a DAQ test, that's delivered audio quality. And then reliability factors have increased the effectiveness of systems like these, and codes have been modified to reflect the new technology that's available. So we're going to talk about battery backups. We're going to talk about the alarms. We've already mentioned the NEMA 4 enclosures, which protect the components. But then now the question is, how do you know whether the radios are going to work in your building? You don't wait for the disaster to happen. So you can do a delivered audio quality test. This is an audible test for coverage to see whether there's an issue that needs to be addressed, or to see whether it passes, it will pass the AHJ inspection. So in order to do this test, the building is segmented into 25 to 50 foot grids, depending upon the ordinance or the code. 2 people, each with a radio on the specific county or city frequency. One person is stationary, and the other walks the building and transmits a test in each grid, and the other records the audio quality. So the audio quality, when you look at this, you see a DAQ of 1.0, which is unusable, up to DAQ of 4.0, which is speech easily understood. A minimum of 3.4 is the passing grade. So you can see on this chart the various levels of clarity recorded, but this is the standard DAQ test. So this test works, but it's highly subjective, even though the definitions are clear. That's because everyone hears and interprets differently. For this reason, the AHJ, the fire marshal, usually wants to be present for the final DAQ test before acceptance. Then a report is usually produced showing the results for each grid. As we saw earlier, 90–95% of the building must pass. So counties are starting to adopt one of the codes, and in some cases writing their own ordinance. Cities are the same. For instance, Baltimore and Washington have their own ordinances, citing the NFP 2010, but Annapolis adopted the Anne Arundel County Code, which also cites NFPA 2010, but also adds a process for design, approval, and permitting, which is not included in many other county ordinances. So many of the newer ordinances require compliance if the building is over a certain size and any new construction over a certain size, including renovation. There's a township in Pennsylvania, Upper Allen Township, that recently passed an ordinance requiring any building over 32,000 square feet be tested for public safety, and the building owner would have 6 months to correct the problem if the building didn't pass. So we mentioned the AHJ earlier. The AHJ may, in some counties, also include the radio shops that manage the radio system for the county. So it's good to talk to them to find out which people are part of the AHJ. It's also very important to look at the codes and adhere to the codes in conjunction with the AHJ, because certificate of occupancy is usually something that may be withheld if you don't adhere to the codes, whichever code was adopted. So let's look at the specific codes. There are two major fire codes: the National Fire Protection Association, the NFPA, and the International Fire Code, the IFC. So both documents are available for purchase, but if you go online, they've got a regular website, you can pull them up and they will let you review the document. They don't let you download the document, but obviously if you do some screenshot or screen cut, you can pull your piece up for review. They're both very, very large documents, as they are the entire code, but I've listed the specific sections that pertain to two-way radio communications, and that's where the distributed antenna falls under two-way radio communications. The actual section describing the specific code for this application is only about 1 page on each, but it's in a very, very large document. In some ordinances, you may see an entry that says reference NFPA 1221. The 1221-2016 is actually part of the NFPA 72, and it acts like an appendix. So a lot of the ordinances now just reference the 1221, which references back to NFP 72. So from our experience, different areas of the country tend to prefer one over the other code. What we've seen is the East Coast is more NFPA, but it's always up to the county zoning and or the AHJ as to which code they adopt. Code highlights. The two individual codes get updated approximately every 3 years, and usually, as we said before, to follow the developments of the technology. So you see the IFC on the left and the NFPA on the right. This is a chart that compares the top four changes in each document between the two versions of each code. And we'll go through them: coverage, secondary power, alarming, and retesting. These are really the top ones that people need to be concerned with. So when you look at coverage, you see a lot of dBMs, that's measured in decibels. This is what's tested in order to comply with the ordinances. This would be a more detailed test than the DAQ that we talked about before. These readings are taken using a spectrum analyzer, and it's usually done by the integrator. When you look at the IFC 2009, where it's defined by FCO, that's the fire code official. Secondary power, this has become very important. Secondary power is battery backup or the UPS uninterrupted power supply. Both have changed the requirements in the two versions. So you look at the IFC went from 2009, required minimum 12 hours, to, in the 2012 version, minimum 24 hours, and they don't give any other details beyond that. The NFPA is a little bit different. The NFPA went from 2010, a 24-hour backup unit or a 4-hour backup unit if the building has a backup generator. The 2013 reduced it to 12 hours or a 2-hour battery backup unit plus 12-hour backup generator. Okay, so that's very important to note there. And here's something else. Be aware that just because the NFPA 2013 code says that the requirement is 12-hour backup, it's the version that was adopted by the county that governs. So that means that if they adopted the 2010 version, you must still provide the 24-hour backup. So even though the code was changed to 2013, if they adopted the 2010 and not the 2013, you got to adhere to the 2010 to 24 hours. So that's critical to make sure that you understand the differences. Alarming has become easier because most of the active DAS components now come with the basic alarm contacts that I showed you in one of the slides earlier with the picture of the gray box. We just connect that to the fire panel or the annunciation panel. Retesting, everything says you should do it annually. Retesting is usually deliver an audio quality test. You check the UPS and you check the alarm test. So there are other changes, but these are the big ones. So best practices for distributed antenna systems. So we talked about and showed you the NEMA 4 enclosures. These are now recommended. These are certainly recommended, but they're required in many codes. We just talked about the battery backup. Alarms, they're tied to the fire or annunciation panel, usually in the building control room. In most cases, the DAS is designed with the DMARC box, that was a gray box, for the alarm contractor to connect into. We always recommend that a qualified alarm contractor make this connection, not necessarily the integrator. Annual inspection is required. We just talked about that. Inspection to validate that the UPS component is functioning, an alarm test. We recommend a maintenance contract with the integrator. It's not required by code, even though the testing is, but a maintenance contract for obvious reasons just keeps your system working and functioning properly, and you shouldn't necessarily have to rely on an annual test required by code. Specific NFPA version, what do I mean by that? It's very important to make sure that the integrator that's designing the system is following the requirements in the code. If not, you may get a lower price for the system, but it may not pass inspection, and then there will be added cost to correct the system, and may lead to a delay in the certificate of occupancy, and that could be more costly than the system itself. Determine who is the AHJ. It's good to know who the AHJ is, as we've talked earlier. Have open communication so you understand what code and what requirements you need to have for your building. Anticipate future needs. Have local codes change, plan for the future. You're going to renovate your building. Lots of things can happen. So the life cycle. This just gives you an idea of the life cycle of a DAS project. It's not particularly complicated. Some of it is quite obvious, but you start with your new construction or renovation. We talked about the test. You can either do a test on an existing building to see whether you need to put a DAS in and qualify the coverage. You get someone to design the DAS. Again, we talked about the particular software that's recommended to use. Then you submit the design to the AHJ. Now, that is mostly required, but obviously recommended, because it's better to find out any modifications that you need to make to your system before you construct it and find out later. Then construction is obviously going to vary by the size and complexity of the building that you've got and the system that's been designed, but you can work with your integrator and get a really good idea about the timeline. Then the system gets tested and approved, and we talked about that with the AHJ probably coming with you. Use and occupancy permit is secured. The AHJ then registers the DAS with the FCC. All public safety DAS systems need to be registered with the FCC. If you have an integrator, a lot of times the integrator will help you with that process. Obviously, we just talked about the maintenance contract and annual test. Assuming everything is done well and you have proper maintenance, expect a lifespan of 7 to 10 years. So last topic is shared DAS. So we talked about planning for the future. So you're building a DAS for public safety currently. Are your needs going to change? You're probably all aware a DAS can also carry cellular traffic if designed correctly. So here are the different frequencies. Public safety, it's usually 700 or 800 megahertz. Neutral host, meaning the carriers, and you can have all 4 major carriers, or you can have 1 or 2, your choice. These are the different frequencies they operate in, and there are various bands within these frequencies. And I mentioned that Social Security put in their private radio systems. You've got radio systems in the 400 to 800 megahertz frequencies. So the additional cost to design, build, design and build a system that's expandable up front is usually less than 10%, where the cost to redesign and upgrade later is going to be much more substantial. You may have equipment that needs to be traded out. You may have an antenna design, because when you have you need more density of antennas when you're dealing with cellular, that type of thing. So if you know up front that in the future you're going to want to add any type of cellular, plan for it up front. Your integrator can design it appropriately, and then you can grow into that system at much less investment. Okay, now there's a caveat to that one too. You got to be aware that, you know, even though if it's designed correctly, there isn't any interference between the carrier signal and the public safety, a lot of the ASJs insist that the public safety be in a separate system than any commercial traffic. So that goes back to another reason to have dialogue with your AHJ to find out what the particular code is for that area, so you don't make mistakes and cost yourself some money. So we'll open it for questions. That concludes my piece of the presentation. I hope we've given you some valuable information, or at least pointed out some issues to be aware of when you're planning a public safety DAS project. As I said, if you want a copy of this, just let us know. You have my contact information here. We'd be happy to send you the soft copy of the presentation. If anybody has any questions, we'll try to answer them now. And if we can't, we'll certainly get back to you with the answers. So thank you for your time. Vince?
Absolutely. Thank you, Kip. Thank you all again for attending the webinar hosted by Communications Electronics in partnership with Smart CEO. We have about 5 to 10 minutes left. If anyone has questions that they'd like to put into the chat, we're more than happy to answer them. Thank you. Kip, we have a question. Is AHJ usually fire marshal? What about the police?
The AHJ for this particular, for the fire code, is usually the fire marshal. But again, you want to check with the county and find out who's involved. As I said, the AHJ also can sometimes involve the integrator that built the radio system for the county. So the police may be involved, but it's usually the fire marshal.
Okay, great. Thank you, John, for your question. If there's any additional questions, feel free to type them out. We have another question from Thomas. What are usually the requirements for the DAS in a building versus firefighters' phones?
They're two separate systems. As I mentioned, some of the AHJ are moving away from the fire systems because the fire systems is a static system that you got to have the fire phone, and you can only use it in the area where you can plug it in. The technology of the DAS gives significant flexibility. Basically, your radio is going to work in 99% of the building. So there's a lot more flexibility. But again, it's entirely up to the individual AHJ as to what the code requires and what they'll accept.
Great. Thank you, Thomas. All right, it's 1:30. We'll do a last call for questions if anyone has any additional. We have another one from Jeff. Have you actually seen any AHJ approve this system in lieu of a required firefighter phone?
That is a good question. Personally, I have not, but I will ask our engineer that question. So you want to know in lieu? We have heard of instances in the older or in some of the newer buildings that they have required DAS, but let me confirm that. Confirm DAS in lieu of fire. And who should I respond to?
That's Jeff Moyer. We have his email address. I'll give it to you afterward. Yep.
Okay, Jeff, I'll confirm and get back to you.
Great. All right. Any final questions? John, we can absolutely send you a follow-up with a copy of the slides. All right. That looks to be everything. Oh, actually, we just got one more. Sorry. From Allie, it says, City of Alexandria, VA accepts just DAS systems.
Ah, okay. That's good to know. Thank you, Allie. Another reason to keep talking to your AHJ to find out about the code changes.
Okay, perfect. Kip, did you want to just take a minute to talk about communications electronics as you did in the beginning? Just a quick overview.
Sure. We're a systems integrator in Maryland. We operate in the Mid-Atlantic District, Mid-Atlantic region. We do distributed antenna systems. We design, install, commission, and test and maintain distributed antenna systems for all frequencies. So we've done a lot of single public safety, a lot of cellular, and a lot of combination systems, usually in commercial office space, hospitals, school systems, so government buildings. So if anybody needs any help, obviously we'd love to help you.
Excellent. Thank you. And thank you again, everyone, for attending. We'll send out a follow-up if anyone would like more information, and we'll definitely respond to any of the questions that you had and send out a copy of the slides. Thank you again.
Thank you.